is problem 5 from problem set 8. It's the repeated study date game. So interesting about this is actually a mixed strategy Nash can be punishment as well. So let's get to this. So the first thing obviously is to figure out the Nash equilibrium in the second round. So in the first round we don't care. So in the second round, second stage, there are two pure strategy Nash and there is one mixed strategy Nash. So the mixed strategy Nash is specified with 4 probabilities. If you only have 2, it's okay as well. Just pick the first 2. But 4 is more clear because what this means is the first player will play the first action with probability 3 over 5 and play the second action with probability 2 over 5, and similarly we have this. So what we're going to do here is there are 3 Nash equilibria. There must be one of them is good, one of them is bad. So obviously these two are actually good Nash equilibria, so there will be this mixed one which is a bad Nash equilibria. I don't know how, so we need to calculate the payoff. So this payoff is 3 and 2, so if they do R and R, they get this cell, so it's 3 and 2. If they do E and E, is 2 and 3. If they do this, we need to compute this. So what will the first person get? The first person, let's use some more space. So this is utility the first person get if they both use this mixed strategy equilibrium. So I will get 3 with probability that I play R and probability that the other guy plays R. So this is the probability of reaching this, and then this is payoff I get. So this is the expected payoff, plus I may get 0 as well. So when do I get 0? If is when I play R and the other guy play E. So it's 3 over 5. 3 over 5. This is not a, this is multiplied. So, and I may get 0 here as well, but this is just 2 over 5, 2 over 5. If both of us know, I mean if it's E and R. And I may get 2, 2. So this is if I play with probability 2 over 5, the other guy's 3 over 5. So this whole thing is my expected payoff. So what's that equal to? This is equal to, I don't actually know. Let's calculate this. So this sum to 5. 5 and 5 cancel. So it's 6 over 5, I think. So let's do this. So it's 1.2. And it should be 1.2 for the other guy as well. So those are my payoffs. And then let's see, this one is less than both of them. So these are the good Nash equilibria. This is good and this is bad. We use the bad one as the punishment. So how we are going to construct the Nash equilibrium that works with split and split, as I did in the previous videos, you always do the same thing. You always put what you want, which is specified in the question. In the question, I will tell you what this is. You always put this, and then you put the good Nash equilibria in the first place, which is say 3 and not. You don't want to do that. That's wrong. So R and R after the history that we want. I copy this here after history. Split and split, and you always do the bad one. If there's no bad one, remember sometimes you do the punishment strategy pair, punishment strategy profile, but here we have a bad one, so let's use this. So bad one is the mixed strategy. Yeah, this is allowed to write 2 over 5, 3 over 5 after. It's always the same thing after all other histories. So again, good after this history that we want and bad after all other histories. And then the next step is always to check. You need to check this on the exam. So check if I follow the plan, what I will get. Follow the plan. And then if I cheat or if I deviate, what will I get? So if I follow the plan, let's look at this. Follow the plan means split and then R. So split is 0.5, R is 3. So that works. Split is 0.5, R is 3, so it becomes 3.5. So this, remember, this is for me. So for player 1, let's say. And then if I cheat, what do I get? So if I cheat, then I want to cheat optimally, so obviously I want to steal, so I get 1 in the first round. In the second round, how do I cheat? This is a Nash already, so the best response to this thing is just this thing. So because I'm indifferent, so I don't really care. So okay, so that's the best response, and let's say what I get from this is 1.2. So what happens is if I cheat, I get 1 in the first round from steal, and then I still do the same mix in the second round because again it's the best response. So it's 1.2, which in the end you get 2.2, and 2.2 is still smaller than this 3.5. So following the plan is preferred. One problem with this game is asymmetric. So if you are the first player and if you're the second player, you see a different game. So, well, I need to do it again for player 2. That's all you need to do. Okay, my handwriting is getting too stupid. So if I follow the plan, then I get 0.5 plus 2 now. So because this is the second player, it's 2.5. If you cheat, we get the same thing because it's kind of symmetric. It's not really symmetric. You should recompute whatever this thing is, but then you will get the same number. So it's 1 plus 1.2, so it's still 2.2. This is still larger, so there will be no deviation. So to combine them, both of them are not having incentive to deviate, so this whole thing is an SPE.